access codes to the Xeon mainframe.
In today's world, a mainframe is not the first thing that pops into our mind when we think about high volume and complex data processing. This is because mainframe computers are often seen as ancient machines or the dinosaurs of computing world. To the surprise of many, there are about 10,000 mainframes in existence today. They are used almost exclusively by the largest companies in the world. This includes 7 of the top 10 global retailers, 8 of the top 10 insurance companies, 45 of the world's top 50 banks, top 10 telecommunication companies, and 2/3 of Fortune 500 companies. Most of these mainframes are made by IBM. The tech giant positioned itself to become the most important and the only vendor when it comes to the production and supply of these highly specialized machines at a scale. Many would be forgiven for thinking how on earth companies still use these machines on the age of cloud computing and edge infrastructures. Well, there is a good reason for keeping them after 5 decades of existence, and I will address the reason why just in a moment. First, I will touch upon the peculiarities of mainframes. It is mind-boggling when we see the sheer power and the size of current generations of mainframes. Today's mainframe can have up to a whopping 240 server-grade CPUs, 40 TB of error-correcting RAM, and many petabytes of redundant flash-based secondary storage. Since mainframes designed to process large amounts of highly critical data while maintaining 99.99% of uptime, they are well suited to cater for the needs of many big banks and financial organizations. Financial transactions are the main beneficiaries of the raw power and reliability of mainframes. A medium-sized bank may use a mainframe to run 50 or more separate financial applications and supporting processes and employ thousands of support personnel to keep things running smoothly. The overwhelming majority of mainframes today can process high-volume financial transactions, which include things like credit card purchases at a cash register, withdrawals from ATM, or stock purchases on the internet. Since financial transactions are time-sensitive and mission-critical, they need a setup that ensures rapid responses, reliable data exchange, and bare minimum downtime. Banks have to ensure their customers that their systems run without any hiccups, even during shopping holidays, in order to maintain customer confidence. High-speed data crunching means little if processing stops during business hours, and reliable processing is no good if people have to wait minutes for transaction to complete. Mainframes are designed from the ground up to provide both redundancy and high throughput for these purposes. Components will inevitably fail, especially during high-volume transactions. Mainframes' built-in redundant processing comes in handy. RAM, CPUs, and disks are all hot swappable, so if a component fails, it can be pulled and replaced without requiring the mainframe to be powered down. Mainframes are partitioned independently, each having their own components such as CPUs, RAMs, and operating systems to allow application run continuously, while certain partitions receive maintenance in the form of OS patches, hardware fixes, and upgrades. The CPUs that we find on mainframes have unique features that makes them stand out. IBM's Telum CPUs are capable of doing more than just correcting bad memory bits, unlike other server-grade CPUs found on the market. IBM mainframes can detect and recover from failed hardware memory channels, failed DIMM memory chips, and failed CPU operations. This is critical for ensuring smooth and uninterrupted operation. The latest iteration of IBM's Telum CPUs are built on Samsung's 7nm fabrication process, and it's optimized for single-thread performance. Clocked at 5.2 GHz is plenty powerful to handle complex tasks at high speed. Compared to the counterpart CPUs made by Intel and AMD, Telum has higher clock speed, more cache, more specialized on-CPU hardware, and more PCI channels for moving data. These Telum CPUs are based on the power architecture that IBM is developing for the last 30 years. The current gen of Telum CPU has a mouth-watering specification. Each core is two-way multi-threaded, supports up to 256 KB of L1 cache and 32 MB of L2 cache, and supports superscalar instruction execution. A fully spec'd out IBM mainframe can support up to 250 cores, 190 of which are user controlled. I/O is handled by two PCI Express 4.0 controllers. Mainframes usually run purpose-built operating systems to optimally support their purpose-built hardware components such as the CPU. IBM has its in-house developed closed-source operating system called ZOS, specifically designed for its Z architecture family of mainframes. Released way back in the year 2000, it is a 64-bit operating system which is backward compatible with 24 and 31-bit applications. ZOS supports LPARs, or logical partitioning of system resources. It is like a modern virtualization setup where processes, memory and storage divided into multiple segments, allowing each set of resources to be operated independently with its own operating system instance and applications. Each LPAR can run a separate, isolated instance of ZOS, the mainframe operating system. This is very essential for fault tolerance. Besides logical resource management, ZOS also offers security features like security server, resource access control facility, and pervasive encryption. In terms of programming language, ZOS natively supports applications written in C, C++, COBOL, Fortran, PL1, and Java programming languages. The mainframe software stack mainly composed of COBOL programs, data file, job control language, and customer information control system. COBOL currently mainly used in applications deployed on mainframe computers. Its declining popularity means companies are forced to migrate their enterprise applications to newer platforms. However, COBOL-based programs are still being used by most companies that owns mainframes. These programs are tailor-made for batch processing and non-interactive jobs. Job control language is another key component in the entire software stack. The purpose of the JCL is to instruct the OS what program to run, where to find the input data, how to process the input data, and where to put the output data. Since it has no defaults, everything must be written out in sequential job control statements. Apart from batch processing programs, mainframes also usually deploy container-based applications to perform specific tasks such as high-volume financial transactions. This is where the Customer Information Control System, or CICS, comes in. The CICS can run applications written in different third-party programming languages such as Java. It presents a high-performance API-based container where dedicated code can run in place. Despite their exuberant costs that can reach up to $4 million, mainframes are still relevant today, albeit in narrower scope than before. This is because they fill the important niche of processing high-volume, business-critical financial transactions. One of the reasons why it's extremely hard to replace mainframes is tied with legacy codebase. Essential COBOL-based applications are still being widely used, and replacing them with newer platforms is next to impossible. Fortune 500 companies have been using the same COBOL codebases for decades. The original COBOL developers are either moved away from it or died. So it's extremely difficult to orchestrate conversion to a newer standard without incurring a massive cost and grueling process. This is why many companies have tried and failed at conversion. Even if alternative to mainframes such as the one provided by FIS Global exists, big banks are still highly hesitant to adopt new technology. By trait, banks are risk averse. They are often slow to adapt new technology and only do so when under competitive and regulatory pressure. So what do you think about the relevancy of mainframes in the current tech age? Do you think that they still have a place or we should move on? Give us your comments. Thanks for watching.